Today in Chapter 8, we're going to combine formulas of compounds and the calculation of empirical formulas. An empirical formula is the simplest whole number ratio of atoms in a compound, and the empirical formula can be found from a percent composition of the compound. Empirical formula, for example, CH, and this is in a 1-to-1 ratio. It's the simplest whole number ratio. A molecular formula is a multiple of that. So the molecular formula may be C6H6, but we can reduce that to lowest terms like we would talk about in math class and reduce it to CH. So the molecular formula, how it really appears as C6H6, its simplest whole number ratio would be CH. That's the difference between empirical and molecular. Sometimes also that I want to make a point here to point this out. Let's talk about water, for example. So H2O, that is the simplest whole number ratio between those two elements, 2 hydrogen to 1 oxygen. So its empirical formula is the same as its molecular formula. So H2O empirical and H2O molecular are the same thing. Let's do some calculations of empirical formulas. A gaseous compound containing carbon and hydrogen was analyzed and found to be 83.65% carbon by mass. Determine the empirical formula of the compound. All right, a couple of things. When we're given percentages, we can assume that to be grams. Not assume it, but change it to grams. Because if we have a 100-gram sample and 83.65% of it is carbon, that means out of that sample, 83.65 grams, because that's 83.65% of 100, is carbon. So where's the other part? The other part is hydrogen. So if 83.65 is carbon, we take 100 minus 83.65, and we come up with hydrogen being 16.35 grams for hydrogen. And that gives you a total of 100 grams. Okay, back to how we set up the problem. It's very important that you follow these instructions, because if you don't, you're going to come up with a lot of wrong answers. So let's start by coming over here and saying, this is what we have to deal with. We have 83.65 grams of carbon, and we're going to write our other one down below it, 16.35 grams of hydrogen. I want you to be very careful to follow the instructions. So you start giving yourself this much space. The first thing that we're going to do is we're going to change grams to moles, because we've talked over and over in this chapter how we can't compare grams to grams. We have to change it to moles first. So you know how to do this. You're a pro at this now. We go to the periodic table and we find out that carbon is 12.01 grams per mole, and we know that hydrogen from the periodic table is 1.01 grams per mole, and that allows us to cancel grams and to get on an equal playing field. So we're going to take 83.65 divided by 12.01. Here's where something different happens that I've been telling you to round 2 places past the decimal. When you get to this step right here, I want you to be very careful to take it out at least 4 places past the decimal, because the more exact this number is, the easier the rest of our problem is going to be. We take 16.35 divided by 1.01, and we have 16.1881. And this is moles of carbon, and this is moles of hydrogen. Now, the next step is to take the smallest number of moles and divide it through everything. So if I have 3 different elements, the smallest number of moles is what I'm going to divide through by each one. So in this case, the 6.965 is the smallest, so we're going to divide both of those. We know that that's going to be 1 mole of carbon, and the ratio here then, 16.1881 divided by 6.9650, that will be 2.324 moles of hydrogen. Okay, now that we look at those, we hope to have whole numbers here to make our life a little easier, but this time we don't. So what you have to ask yourself is, okay, what number can I multiply this number by to get a whole number? When you have 2.3, generally multiplying by 3 is going to get you a whole number. When we do this, it's going to be 6.973, which is right at 7 moles of hydrogen. The reason we did this is because we're trying to come up with the lowest whole number ratio. And we can't do that without having a whole number here. This place right here, if it's a 0, round. If it's a 5, you know to multiply by 2. If it's a 0.97 or 0.9, that's roundable to 3. But it's not. This is 0.3, so we're going to multiply the whole thing by 3 to get 6.97, which is really close to 7. Whatever we do to one, though, we have to do to the other, so we're going to multiply this times 3 as well. So our empirical formula will be written as C3H7, and that's our empirical formula. All right, let's look at an exercise that's going to help us do this again and give us another example to go by. And this time we have 3 separate elements in this compound. And they tell us that this is 49.3%, 6.9%, and 43.8% by mass, which means that if you add these 3 up, you get 100%. So I can say that that is 49.3 grams of carbon. Down here and put 6.9 grams of hydrogen and 43.8 grams of oxygen. This would be a good place for you to pause the video and try to work these out just like the problem before this. I'm going to go ahead and work it out here, but like I said, it would be best if you paused it and tried to work it out yourself. The first thing you do is change grams to moles because we can't compare masses. So we have 1 mole is 12.01 grams. Again, this is easy because we've been working on this for a week and a half now. 1 mole over 16 grams per mole. Let's do the math. 49.3 divided by 12.01 is 4.1049. And like I said, string these out to about 4 places. It's going to help you out the most. 6.9 divided by 1.01 is 6.8317. This is moles of carbon. This is moles of hydrogen. 43.8 divided by 16. 3.8 divided by 16. 2.7375 moles of oxygen. Now that you have this written out, you look at the smallest of the 3 numbers. The smallest one is this one, so we're going to divide through by the smallest number. It's going to give us 1 mole of oxygen here. Divide this number by 2.7375 and this one by 2.7375. Let's do the math. 4.1049 divided by 2.7375. That's going to be 1.499 moles of carbon. 6.8317 divided by 2.7375. We have a total of 2.4956 moles of hydrogen. Okay, again, we don't have even numbers, round numbers, close to whole numbers, I should say, not even numbers, but close to whole numbers. So we have this, and this is really close to 1.5, of course, and 2.5 is this one, and then we have 1 down here. And you know that if you multiply this times 2, that's going to give us a whole number. 1.5 times 1.5 is 3. Whatever we do to 1, we do to the next one. 2.5 times 2 is going to be 5. We also have to multiply it times 2 down here because we have to be consistent, and that's going to be 2. So our empirical formula is going to be C3H5. That's where that comes from, and O2. This is our lowest whole number ratio. You can't go any lower, reduce any more unless you're dealing with decimal points, and we don't want that. We want a whole number ratio. So that is our empirical formula for this problem. And that's how you do the calculations. Be meticulous about writing each of these steps out, because the more I can follow your work, the more credit you get on the test.